studying about the some basic concepts of mathematical physics only that is required in doing your electromagnetic theory derivations. So it will be basically your maths kind of class only. So we will be talking about various basic maths concepts which are actually essential to solve certain derivations or questions in your electromagnetic theory. That is the reason we are going to introduce you some basic concepts which you all must be aware earlier also. Okay. So there are basically two quantities which are existing there in nature. Those are scalar and vector quantity. Okay. So these are two every physical quantity in this nature, every physical quantity in this nature is either a scalar or it's a vector. So what's a scalar? Scalar quantities are those which has only magnitude term. The only value is considered here and it do not involves the direction. Direction is not considered. And if we talk about the vector, it involves both magnitude and also the direction about the physical quantity. So it can be a unit of some same kind, scalar quantity. It can be a number stating how many times the unit is contained in the quantity. So it's a scalar quantity. So if we want to point out some examples for scalar quantity, so examples are mass, volume, any example you want to give, density or temperature. These all are scalar quantities. What are the examples of vector quantities? Anyone from the class?
Ma'am, velocity, acceleration.
Velocity, acceleration, force, stress, displacement, vector. Okay, these are all vector quantities. So vector quantity is a number which is giving the magnitude of the quantity in terms of its unit and also a statement for its direction. So both the things are involved here. Okay. So let us see some laws, basic laws of vectors. Okay. First of all, let us study some laws of vectors. First thing is addition and subtraction of vector. Addition and subtraction of vector quantities. How it happens? Okay. So if I have two vector quantities, like first is in this direction A vector, second is oriented in some other direction B vector, and both are making an angle somewhat equal to theta. So the resultant amplitude or resultant vector will be given by joining this particular line. This is a parallelogram joining the start point and end point. That is the C vector, or you can say V vector. So we can simply say C vector is equal to A vector plus B vector. Okay, where actually the magnitude of the C vector, magnitude of C vector is actually equal to under root A square plus B square minus 2AB cos theta. This is how we write the vector. Okay. So vector addition, the first property we can say it is commutative in nature. If you want to mention some property, it is commutative. Commutative nature means either you are adding A first to B or you are adding B first to A, the result will remain same. So I can say C vector is equal to A plus B vector, which I mentioned earlier in the diagram, but it is also equal to B vector plus A vector. Doesn't matter. The you can say the order doesn't matter in this commutative law. Vector addition is also, first we are talking about vector addition. Vector addition is also associative in nature. Associative property tells you like if we have some kind of thing like we have A vector plus B vector and then we are adding the C vector. First we are adding A vector to the B vector and then adding the sum to the result to the C vector. It will be remain equal to if you add B vector and C vector first and then add the quantity to the C vector. So it will be a same thing. So vector subtraction is obtained by reversing the sign of vector which is getting subtracted. Again, that will also follow the commutative and associative. Okay. Then comes vector multiplication. Okay. So multiplication of vector can be in two forms. Multiplication. No. Okay. First can be scalar product of two vectors, and second thing can be the vector product. Scalar product is also called as dot product, and vector product is also called as a cross product. Now, if we want to find the scalar product of two vectors, like vector A and B are there, again making some angle theta. Okay, so we can say here A dot B is equal to AB cos theta depending on the angle which it is making. Okay, and if we want to talk about the vector product, so if again we have two vectors, A vector and B vector, making some angle theta lying in same plane. Then the third vector, or you can say cross product of these two vectors will be giving a third vector which will be perpendicular to both the vectors A and B. So we can write it as C vector is equal to A vector cross B vector, or AB sine theta. Sine 90 is 1, so again it is giving a third vector which is perpendicular to the first two vectors. Okay. Then comes some multiplication results, that we have unit vectors I cap, j cap, k cap for your Cartesian coordinates along x-axis, y-axis and z-axis. So we know that the basic things are I dot I cap, j dot j cap, these all quantities are equal to 1 because the angle along the same plane will be 0 and cos 0 is 1. So it is 1. Again, for vector product, I cross j cap equal to j cap cross k cap is equal to k cap cross I cap. Okay. Sorry, these this is equal to I cap dot j cap is equal to k cap. J cap dot k cap will be equal to I cap, and k cap dot I cap will be equal to j cap. This is how we get the third vector which is perpendicular to the which is perpendicular to the two vectors which are for which we are taking the cross product, similar to this particular definition. I cross j is k is the along the z axis. Okay, so this is the, you can say, vector multiplication to the unit vectors of Cartesian coordinate system. Okay, and if we talk about the same vector multiplication of vector product of same vector, it will be 0 because the sign of 0 is 0, because sign of 0 is 0. So these are basic things which you already know. Now the new thing that we want to introduce to you today is about the field. What is actually a field? Can anyone tell anything about field? What is a field? Like, you must have heard about electric field, magnetic field, but how do you generally define a field? So field basically means, it talks about the both the region, means both the region and also the value of physical quantity in that particular region. So field is talking about both the region and value of physical quantity in that region, that is given by the field term. So electric field, magnetic field, gravitational field are the examples of these fields. Now field can again be of two types. It can be a scalar field, and the other type of field is a vector field. You already know that electric field, magnetic field, these are vector in nature, right? So if we talk about the scalar field, so if we say physical quantity is a scalar, if the physical quantity about which we are talking is a scalar, then it's a scalar field. And if the physical quantity about which we are talking in the region is a vector quantity, then it's a vector field. For example, electric field, magnetic field. And if we talk about scalar one, temperature, potential, these are potential, scalar potential. So these are the scalar field examples. Okay. So this was all about the field. Okay. Then comes the concept about partial derivative. So partial derivative we have already talked about in the our derivation about linear wave equation also. When do we take partial derivation? when does the partial derivative comes into role? Can anyone tell me? Bolo? Yes, anyone who would like to say something? This symbol del or this symbol del. These two symbols are used to denote the partial derivative first. Okay. So partial derivative is arising when our function for any function phi is depending on three variables x, y, and z, and I want to differentiate with respect to x only. I want to see the change with respect to x, not in with respect to y and z. So what I will write, because the function is fully defined only when we have x, y, and z, but I am looking at the change with respect to x-axis only. So I will take partial derivative, because phi is not completely getting derivated. We are not differentiating it completely. We are differentiating it partially with respect to x and keeping y and z variables at, considering y and z as constant. So partial differentiation derivation comes into role at this particular point when there are more dependent like more variables independent in nature, but we are doing differentiation with respect to only one variable. Okay, so this is how the partial derivative comes into role. So if I want to define the full derivative of this phi function, I can write it as d phi is equal to del phi by del x dx plus del phi by del y dy plus del phi by del z, then dz. This is how we write the partial differentiation form. Okay, sorry, fully derivative form. And if I want to do it partially, simply it will be del phi will be equal to del phi by del x, or del x like this. So it is a partial differentiation with respect to x only, like this. Okay. Again, the second thing is this particular, the partial differential is an operator. So we can say del. This is a symbol del, which is called as partial differential operator. I talked about operator. What is an operator? Operator is any function which is acting on the operand. Like we talk about addition operator, subtraction operator, multiplication operator, division operator. These are operator examples in simple maths. Again, del is a operator which is called as partial, or you can say partial vector differential operator. It is vector in nature because we will be having its vector value. So it's a vector quantity. This operator is a vector quantity which is actually giving you the value. This del operator has the value del is equal to del by del x I cap plus del by del y j cap plus del by del z del z k cap. This is the value for your partial differential operator with respect to x, y, and z axis. Okay, it will be used at many places in your Maxwell's equation, which will be deriving in the future. Okay, abhi hum in the same unit we have these topics. That is why I'm introducing you these basic mathematical terms, because they are going to be used in your derivations. Okay, in after after two class only, then you will be using these things in your derivations. Okay, so del operator is denoted by simple del, or we call it that nabla also. The symbol is called nabla also. This is a vector differential operator whose value is this. Okay, this must be in your mind that value of del operator is del by del x I cap, del by del y j cap, del by del z k cap. Okay, then comes like, so this del vector is having all the properties of an ordinary vector. So it's an operator. So its magnitude has no physical significance. If you want to ask me that, ma'am, it's a vector, it is giving directional terms also, then what about its magnitude? Actually, its magnitude has no physical significance. Okay, so then comes another operator which we will be talking about, that is a Laplacian operator. Okay, so it's a dot product of differential operator. Dot product of differential operator gives you the Laplacian operator. Now this Laplacian operator is a scalar quantity. It has only magnitude, no direction. So because we are taking dot product, so it will be equal to, what will be the value of Laplacian operator? Anyone who can answer this? You know the value of
Del
del
square
operator.
upon
Yes,
del x square
very good.
plus del square upon del y square plus del square upon del z.
Perfect, perfect. So this is the value of Laplacian operator. It's a scalar quantity, and this is, again, this will be used in your derivations part and for solving certain questions also. So you need to remember these values. You will be doing these things in maths also. Okay, when you will be doing partial differentiation form, then this will be introduced in your mathematics concepts also. Okay, these are used in physics also. Okay, so this is basically about the operators which are there in your syllabus. Okay, now, okay, let us come to some other concepts. I will be introducing you to some new terms that are gradient, divergence, and curl. Okay, okay. So as you can see here, the first thing that we need to observe is about a gradient. Now these are again operators. We are just talking about operators, and gradient is the first type of, you can say, operator. Again, we will be using our del operator in defining these terms. Have you ever heard about gradient operator, divergence, and curl? Have you heard about these terms before in maths? Class, have you heard about
Yeah.
these? Okay. So any idea that you want, like any idea, like what do you know about this gradient operator? Like what is gradient all about? Can you please share whatever you know about this? Hello. Okay, let us do then. Okay. If we have a phi function again dependent on x, y, and z coordinates, okay, it's a scalar function. We are taking phi as a scalar function, not a vector quantity, but a scalar function which is dependent on position coordinates. Okay. Then its partial derivative along the Cartesian coordinates will be del phi by del x, del phi by del y, and del phi by del z. Okay. So the gradient of scalar function, gradient is always acting on scalar function. The first thing you have to remember, gradient itself is a vector quantity. It acts on a scalar function. The scalar function we have defined here is a phi function, again, which is dependent on x, y, and z variables. So gradient of scalar function phi is defined as, it will be given by grad phi is equal to I cap del phi by del x plus j cap del phi by del y plus k cap del phi by del z. Okay. So here we can see the gradient is a vector quantity acting on a scalar function, but again in the end it is producing a vector quantity. So result is a vector quantity. So this is about the gradient. Okay. Now what does it actually tells you? It's a vector. Okay. It is actually telling you the rate of change of function phi. How the function phi is changing along every direction. This is given by the gradient term. Okay. So gradient of a scalar field is defining a vector field, the magnitude of which is equal to the maximum rate of change of phi function here, and direction of which is the same as direction of displacement along which the rate of change is maximum. Direction will remain same. It won't give you some other direction which is perpendicular. Depending on your function and the gradient vector or operator. So it will just give you the how the function is changing along that particular axis. Okay, that is the gradient. Okay, so if if I want to give, like, okay, and let me give you some question to make you explain better about the gradient. How do we calculate it? I- Is this clear to everyone? Whatever I told you about gradient, like physical significance, how we define it, is it clear to everyone? Is this slide clear to everyone? Should we move further?
Yes.
Okay. So, let us solve one question based on it. So it will be bring you more understanding about gradient. If we have a function phi x y z defined as 3x square y minus y square x. Now my question is, calculate the grad phi for points 1, -2, -1. Can you try calculating this? Simply what you will do, grad phi is equal to I cap. So solution is here, I cap del by del x plus j cap del by del y plus k cap del by del z, all acting on the function phi. Phi is already given, so I need to differentiate it, simply differentiate every term. Okay, so it will be this operator, okay, acting on 3 x square y minus 3 y square x, or simply I can write it I cap del by del x. X terms are in both the expressions, so I cap will be having it will be having value 6xy minus 3y square. And if I see about j cap, y terms are also there, it will become 3x square minus 6yx है ना, so it will be 3x square minus 6yx. Then if I see k cap, there is no z term, there is no z term, so it will become 0. Okay, so my answer will be I cap this expression plus j cap this expression. So let us put the value of x, y and z as given in the question. X value is 1, put x equal to 1 and y equal to -2. So if you put this -12 minus, and this will be y square 12 plus j cap 3x square 3 minus 6yx plus 12. Is it right or no? So the answer will be, it will be plus, right? So it will be plus. Okay, so your answer will be -24 I cap plus 15 j cap. This is the gradient of this particular function phi. Is it clear to everyone? How do we find the gradient? Why I am trying to make you understand how to find gradient? Because in derivation, at some steps you will be finding out these operators, how they are acting on equations, on electric field, magnetic field, while deriving your electromagnetic wave equations. Okay, so this will be, these concepts will be used there. Is it clear, class?
Yes, ma'am.
Okay. So next question, this is very important result in your derivations which you will be solving here. And what I will do while doing the derivations part, I will say simply that we know the value is like this only. Okay. We won't be solving at that particular point. We are solving it here. Even in your book, the steps are not given. I have referred some other books to see these questions. Okay. So there's a question purely on subject that prove that gradient 1 upon r to the power n, r is a position vector, is equal to minus r minus n r to the power n plus 2 times r vector. Okay, and that in question where r vector is equal to, we know xi cap plus yj cap plus zk cap, or you can say mod of r is under root x square plus y square plus z square. Okay, this is how. Okay, so if we have to prove this particular part, you will be solving it. So in derivation, why are we are doing this question here? Because it is there in derivation that we will be putting directly this value, the position vector is involved in the derivation, and we will be directly putting the value equal to this thing, and we won't be solving it, and you need not show it in your examination also. but we need some proof that why we are writing it equal to this particular value. So let us solve here while I am introducing you these concepts. So that is my way, like make it solve when I am introducing the gradient concept. Okay, so gradient 1 upon Rn, what will we do? We will write I cap del by del x, which is the value of gradient, j cap del by del y plus k cap del by del z. What will the value of 1 by Rn? It can be written as, बोलो क्लास, पावर में क्या आएगा बताओ, to the power
n by 2.
very good, n by 2, but it is we are adding a numerator, so it will be minus n by 2. Is it clear? Is it clear? देखो ना यहाँ पर है, ये 1 by Rn है.
Yes, ma'am.
ओके, तो हमने ग्रेड की वैल्यू तो यहाँ रख दी, एंड 1 by Rn ऊपर ले गए माइनस n हो जाएगा. ठीक है, इट्स फाइन, आपने सही बोला है. ठीक है, now simply you have to differentiate them partially. Okay, so how it will come? It will be minus n by 2 x square plus y square plus z square minus n by 2 minus 1 multiply by 2x. This will be your I cap term. Similarly, you will get the terms for j cap and k cap also, minus n by 2. Those terms will be similar because everything is same, just the differentiation with respect to coordinate axis, this is changing. Everything is same, x square plus y square plus z square to the power minus n by 2 minus 1 multiply by 2y. Yes, very good. And j cap will come here plus k cap, again same thing, minus n by 2 x square plus y square plus z square minus n by 2 minus 1 multiply by 2z. This is our whole term which has come after differentiating your x term, your I cap term, j cap term and the k cap term. Now we know that this quantity x square plus y square z square, okay, this is coming out minus n by 2 minus 1, so it will be actually equal to 2 in the LCM minus n and minus 2. We can write it in this particular format. So this is actually, if we take minus sign outside, so this can be written as minus n plus 2 upon 2. Okay, so I can write this term as, let us cancel this, 2 with 2 everywhere, 2 here and 2 here. So I am left out with n. N is common in every expression, so I can take n outside with the minus sign, so minus n has been taken outside. Now within the brackets I have x square plus y square plus z square, everywhere common again, with the power minus n plus 2 upon 2. So I can take this also at outside, right? X square plus y square plus z square to the power minus n plus 2 upon 2. Then multiply it by whole equation. What is left here? Xi cap, yj cap and zk cap. So I can simply write xi cap plus yj cap plus zk cap. I'm again mentioning, I won't be solving again when we will doing derivation. I will directly write these values. So please pay attention and understand here itself how we are getting the values. Okay. So simply minus n, this term. So this is actually equal to the quotient term, right? Is it clear to everyone? कैसे हमने प्रूव किया? ये आगे ना टर्म हमारी, इसको डिनोमिनेटर में ले जाएंगे, it will be a positive term then. So r to the power n plus 2. Okay. Then again this is your r vector term and multiply by minus n. That is fine. Is it clear? This is how we prove this term. Okay. Okay. So in the now this is done till this point. So in the next class we will be starting up with the divergence part. Okay.
Okay.
Yeah. Is there anything you want to ask from today's lecture?